biomechanics project, we chose to analyze the deadlift. This presentation will go over the torque and power involved in a deadlift.
Torque is the ability of a force to cause rotation on a lever. Torque is dependent on the amount of force, the angle of application of force, and the moment arm. During a deadlift, there is torque at the following joints: the hip, knee, vertebrae, and ankle.
Some of the factors that affect torque are the force that the muscle produces to lift the weight, the angle between the direction of force and the distance from the point of interest to the point at which the force is applied. The heavier the load that the athlete is lifting, the larger the torque magnitude will be. Different variations of the deadlift can produce different amounts of torque on the joints.
Torque can be seen at all three phases of the deadlift: the lift-off phase, the knee passing phase, and the lift complete phase.
Thompson et al. Found that the greatest amount of torque produced in the deadlift was during the lift-off phase, and the least amount was produced in the lift complete phase. In the concentric lift-off phase, hip extension, knee flexion, and ankle plantar flexion will be occurring. The angular motion of these three movements are in the clockwise direction, meaning they are considered to be negative torques.
The line of action of these muscles pulls the lumbar vertebrae together and creates a compression between them. The weight being lifted and center of mass of the upper body and arms are a relatively long way from the vertebrae, which creates a huge torque. The force required to lift the bar off the ground must be bigger than the weight of the bar and upper body. A component of this force acts as shear across the L4-L5 joint, which can be particularly problematic. This is a visual of the forces placed on the lower spine during the deadlift. The figure shows the line of action of the muscles, and a component of this force acts to counteract the shear force.
Muscles are what create torque on our limbs. Because of the weight is picked up directly from the floor, a great deal of force is placed on the lower back, presenting a significant opportunity for injury. In order to reduce the risk, technique with a neutral spine is practiced in order to reduce the torque on our small lower back muscles. In a Bird et al. Study, they explain that if you keep the bar close to your thigh instead of directly under your shoulders, it reduces the amount of torque on the lumbar spine.
This is a visual example of proper and improper form in the deadlift. The first subject is performing the lift properly with a neutral lower spine. The second subject has a rounded spine, which increases torque on the lower back and increases the chance of injury.
Work done in a deadlift can be calculated as a change in the mechanical energy. In a deadlift, the mechanical energy is the change in potential energy, since there is no kinetic energy at the beginning or end of the deadlift. Work is done when the barbell is lifted from the ground, and the potential energy is calculated as mass times gravity times the change of height. So work is being done when the barbell is moving.
The factors affecting the amount of work being done are the mass of the barbell and the added plates, which will change the amount of force the athlete needs to produce to perform the deadlift properly. The height of the individual will also affect how far the barbell needs to travel to complete the deadlift.
In a study done by Swinton et al., they observed a straight barbell deadlift versus a hexagonal barbell deadlift. The hexagonal barbell deadlift produced significantly greater peak velocity, peak power, and peak force. The shape of the barbell altered the length of the resistant moment at the joint due to the more upright position of the back.
In the case study by Blatnick et al., the purpose was to find out how peak velocity, peak force, and peak power affected deadlift outcomes. They also tried to find where the peak velocity, power, and force occurred in the movement. The peak force of both the bar and system occurred at 100%, while the peak force of the body occurred at 30% of 1 rep max. By finding all the peak values, they were able to pinpoint areas to help make the athlete's deadlift stronger and more efficient, Seeing where the peak values occur, it is possible to train athletes to minimize injury and maximize efficiency and strength.
Common mistakes include improper positioning during the deadlift. These mistakes will create uneven and harmful forces on the joints, which can cause serious injury. Improper forces can negatively affect torque and work done while performing the deadlift.